This is section 152. We're going to take a look at some economic functions. So we're going to examine real-life scenarios of function arithmetic from economics. So suppose you're a manufacturer making a certain product. We're going to say X is going to be the production level, meaning the number of items you want to produce in a given time period. Now, throughout this entire process, we're going to be defining certain things. So if you see this function, c of x, we say that that is our cost function, and it's going to calculate the total cost of producing those x items. So if we say c of 0, that's going to be the cost of producing no items, and we call that the fixed cost. And it represents the amount of money required to begin production, like startup costs. Think about any business. You need some cash in the beginning to be able to start it. Now, c of x is associated with the total cost per item, so that means we can find the average cost, which is c bar. So I know it's not a typo. There's like a bar that's over our c, so we call it c bar, is this function where you take your cost function and you divide it by whatever x is going to be. So if I wanted to find what c of 11 was, or c bar 11, that's going to be my cost function with 11 plugged in divided by 11. And that's going to be the average cost per item. Instead of the total cost, it's going to be the average cost per item. Now to continue with this, we have a few other functions. On the retail end, we call the price P charged per item. So we're going to have this little, it's a small p. We call that the price demand function. And because x is the independent variable, and p is the dependent variable, we have to think of it as this is the price given the demand. Meaning, if I want to sell 5, this is the price that it should be. If I want to sell 10, this is the price that it's going to be. Then we have the revenue function. To find what your revenue is, you multiply x times your price demand function. That's going to be how much you take in. That's how much money you collect after selling an X amount of products. And then your profit function, which is this capital P of X, right? So we have the small p of X and a capital P of X, is your revenue minus your cost. So to simplify everything into one chart, here are all the different functions. Price demand function is lowercase p of X. Now this is something you should get down. I know it's not blue, but this is something that you should get down. Your revenue function is x times your p of x. Your c of x is your cost function. Your average cost function is c bar, so that's going to be your cost function divided by x. And then your profit function is going to be your revenue minus your cost. So let's look at an example here. Let x represent the number of DOPs, media players, or DOPs, however you want to think about it. It is iPod, if I could spell backwards, right? Just being silly. Produced and sold in a typical week. Suppose the cost in dollars to produce X DOPs is given by this cost function, da-da-da-da. So we have a cost function here. And then it says for every x greater than 0. The reason why I say that is because how do you produce a negative number of items? And then it gives us a price demand function. And it gives us the domain of that. I can't produce less than 0, and it's saying I can't produce more than 30 of them. So we're going to go through and find each of these. So it says find and interpret c of 0. So that means I need to substitute x in for my cost function. So I just plug in 0 into my cost function, I get 2,000. This means to produce 0 DOPs, it's going to cost 2,000. So that's my startup costs. Number 2, it's saying find the average cost of 10 DOPs. So I take your cost function and you divide it by the number we're looking for. In this case, it's going to be 10. So what's the average cost of producing 10? So c of 10 divided by 10. If I plug in 10 into my cost function, so you plug in 10, you're going to get 3,000. 3,000 divided by 10, the average cost is going to be 300. So this means 10 DOPs are produced. The cost to manufacture them amounts to 300 per DOPI. So now we're going to interpret P of 0, and P of 20. So that's our price demand function because it's a lowercase p. So if I plug in 0 into my price demand function here, I get 450. This means if no dopies are sold if the price is going to be 450 per unit. Right? So it has like that reverse thinking there. So no dopies are sold if I sell it for 450. If I do 20, that means that to sell 20 dopies, it's going to have to be 150 per dopey. For number 4, it says solve P of X equals 0 and interpret the results. So you have to set P of X equal to 0. So here's your price demand function. You set that equal to 0. Now I just need to solve for X. So, you add 15X to both sides. Divide both sides by 15, ... You're going to get X equals 30. Now this means in order to sell 30 dopies in a week, the price needs to be set at $0. Now to add to this means that even if dopies were given away for free, the retail would only be able to move 30 of them. So you can't move more than 30. Number 5, find and simplify expressions for the revenue function R of X. So to find the revenue function, it's X times your price demand function. So you just take X, you multiply it by your price demand function, you distribute the X, and you're going to get 450X minus 15X squared. Now remember, we have to keep the implied domain. I can't make less than 0, and I can't sell more than 30. And then the next one, it says we need to find the profit function. So to find the profit function, I'm going to take the equation revenue minus cost. That's just something that we have to remember. So I took my revenue function that I just made minus the cost function that's given to me. So I give you that cost function. Now you have to distribute and simplify and combine like terms. You're going to get negative 15x squared plus 350x minus 2000. Now remember, it has the same domain. So if that's going to be, so find and interpret R of 0. So if this is my revenue function, for my revenue to be 0, if I plugged in 0 to that, it means if no dopies are sold, we have no revenue. So if you didn't sell any, we're not making anything. Now your profit, if I plug in 0 for that, that's going to be that if no units are sold, more money was put into producing those dopies than we recouped into sales. Or another way of thinking of it is your profit is minus $2,000. Now, if you remember in the first problem, we found the fixed cost to be $2,000. So it makes sense that if we sell no dopies, we lose those startup costs. So that number was the same as that number. And the last one, solve P of X equals 0. So if we take, now this is capital P, so our profit function equals 0. So we could try and factor it. You could use the quadratic formula. I just factored it. I know that we're still going to review on factoring. That's okay. But I factored it, and I got X equals 10 and 40 over 3. Now what this means is that those represent our break-even points, meaning my profit is 0. I need to sell 10 or 40 over 3 to break even. But there is an issue here. How can I sell 40 over 3 units? Right? Like that doesn't make any sense. So typically what we do is we round one way or another. So let's conclude our lesson. What did we learn today? We talked about economic functions. Now, what's the difference between revenue and profit? Revenue is what we take in. Profit is the money you make. So that means you have to subtract your costs. Now try explaining the price demand function in your own words. The price demand function, that's the little p, it's the price you have to sell, or the price you want to charge your function or your item or your product given the demand. So if you want to sell 20, that would be the price. If you want to sell 50, that would be the price that you need to sell to be able to do that. This does conclude our lesson. If you have any other questions, please leave them in the comments.